Okay, we're going to take a look at this problem here. This is a frustrating problem, actually, in a way. Because we don't have nice, nice numbers. I'm getting a little jaded. X minus 3. Now, x plus 7 times x minus 3 is x squared plus 4x minus 21. So what we want to do is we're going to divide first. So we're going to divide 3x squared plus 5 by x squared plus 4x minus 21. And we multiply by 3. We got 3x squared plus 12x minus 63. When we subtract that, we have minus 12x minus 63, so we got plus 68. And so we end up with this equaling 3 minus 12x plus 68 over x plus 7, x minus 3. Now, what we want to do is use partial fractions. So we're going to say a on x plus 7 plus b on x minus 3 equals minus 12x minus, plus 68 over, I made a mistake here. That's why I'm hesitant. That's minus. So, over, x plus 7 times x minus 3. So we multiply across. A times x minus 3 plus b times x plus 7 equals minus 12x plus 68. Now, if we choose x equals 3, we have a is 0 there, so we have 10b equals, that's minus 36 plus 68, so 68 minus 36 is 2, is 32, and b equals 32 tenths. Now we solve for a. So we have a x minus 3 plus 32 tenths times x minus x plus 7. That's bad 7. Let's make that neater. Equals minus 12x plus 68. Now, if we choose, my my back. If we choose x equals minus 7, we have okay, 12 times 7, that's 14, 7, 84, 84 plus 68, that's 12, 14, 15. That is 152. Let's just make sure. I want to make sure. 152, let's see, 12 times 7, that's 14, that's 84. 84 and 68, that's 12, 152. So A equals minus 152 over 10. So if that's the case, we have B is 32 over 10, and A is minus 152 over 10. So we ran out of room on the sheet. We got to get a new sheet. Alrighty. We have minus. I'm going to get the right color ink. Alright, minus 152 over x plus 7 plus 32. This is tenths. 32 tenths over x minus 3. So let's take a look at that. That is equal to 1/10 times, now we have to multiply here. We have minus 152x, and 152 times 3 is 6, 15, 3, 4, 56. So that is plus 456. Okay, plus 32x plus 32 and 7 is 14, 21 and 22, so 224 all over x plus 7 times x minus 3. And we have now 152 minus 32, 0, 2, 1. So equals 1/10 minus 120x plus, okay, we have 456 and 224, 10, 8, 6, plus 6, 8, 0, on x plus 7, x minus 3, And with the 1/10, we have minus 12x plus 68 over x plus 7, x minus 3. And that's exactly what we're looking for. Oh, and that is not exactly what I want. To have the screen go cockeyed on me. So, now, getting rid of all of the little extraneous math here, just to make it a little cleaner. Okay, so we got, 32. Well, let's see, what is that? 3x squared. Why does this do this to me? I don't want that to move. Okay. So now we have our integral 3x squared plus 5. I think that's what it was. We'll check it in a second. It is x plus 7, x minus 3 equals 3 dx minus 152 tenths dx over x plus 7 plus 32 tenths dx over x minus 3. Oh, and that was a real there, getting there. So here we just carry out the 3x u equals x plus 7 du equals dx, q equals x minus 3 dq equals dx. So we have minus 152 tenths u du over u plus 32 tenths dq over q. And now we have natural logs. 3x minus 152 tenths natural log of u plus 32 tenths natural log of q, which when we go back to our original plus c, when we go back to our original variables, we have minus 152 tenths natural log of x plus 7 plus 32 tenths natural log of x minus 3 plus c. And we could probably simplify this a little bit, but it really doesn't help. I mean, these are powers there, but they're not going to be helpful to us. So what we're going to do is we're just going to leave it like this. We're going to leave it 3x squared plus 5 over x plus 7 x minus 3 dx equals 3x minus 152 tenths natural log of x plus 7 plus 32 tenths natural log of x, whoops, that's minus 3, sorry about that, minus 3 plus c. And that's our solution. Took 2 pages, but what we did first was divide to simplify the numerator, and then we used partial fractions. It took us a while to get to the solution. Sine x over 1 minus sine x squared dx. Now, the first thing we do is we multiply top and bottom by 1 plus sine x squared. So we got 1 plus sine x squared, and we have 1 minus sine x squared and 1 plus sine x squared. So now we're just multiplying by 1 there, but it allows us to use identities. So here, our numerator is sine x plus, now we're just expanding this to sine squared x plus sine to the third x over, now this we have 1 minus sine x times 1 minus sine x times 1, whoops, times 1 plus sine x times 1 plus sine x. And what that does is it gives us sine x plus 2 sine squared x plus sine x times 1 minus cosine squared x dx, and on 1 minus sine squared x times 1 minus sine squared x. And we know what 1 minus sine squared x is cosine. Whoops. Cosine squared x. So we have down here, we have, breaking this up, we got cosine, darn it, cosine to the negative 4 x sine x dx plus 2. Okay, this is tangent squared x secant squared x dx plus cosine to the negative 4x sine x dx, but that's the second one we have like that, so we bring that out there and we erase this term. And we have one last term to work with. We have minus sign. That's a minus sign. Minus. And we have cosine squared x sine x over cosine the 4x dx. But then that is minus 2. And we have no denominator. When we simplify, there we go. And now we have 3 integrals to solve. Let's just clean things up a little bit. So now we use u equals cosine x du equals minus sine x dx. We have p equals tangent x dp equals secant squared x dx. So or wait a minute, let's I'm jumping. We got u to the minus 4 du plus 2 p squared dp minus, and here we've got u to the minus 2 du, and that's a plus. So now we just do our integrals, and we've got 2/3 u to the minus 3 plus 2/3 p to the third plus minus u to the minus 1 plus c, and u happens to be cosine, so we have 2/3, and we take that out, and this is secant third x. We have this p is tangent to the third x minus secant x plus c. And that's our solution. I know there is an alternate solution where it's equivalent. If we did more manipulating, we could probably reduce it from 3 terms to 2 terms. But at this point, it really doesn't matter much. And this is just as simple to use and much less trouble deriving it. So our integral sine x dx over 1 minus sine x squared is equal to 2/3 secant to the third plus tangent to the third minus secant, and our constant. Here we go. I think we've seen this problem. X plus 1 over x plus 3 dx, and where we have x plus 1 divided by x plus 3, and that's 1, and we have x plus 3, and that's minus 2, so we have 1 dx minus 2 dx over x plus 3. We use u equals x plus 3 du equals dx, and we have x minus 2 du over u, which is equal to x minus 2 natural log of u, but u is x plus 3 plus c. So that was a pretty simple one. We've done those. Here's one. I don't know if we did this one. Let's take a look at this. We got x cosine x dx. I don't think we have, where we use partial fractions. So we're going to choose u equals x du equals dx, v equals sine x, dv equals cos x dx, and so uv is x sine x equals v du, so v du is sine x dx plus u dv, x cos x dx. And that's what we have there. So now we just do our integrals. We have on one side x cosine x dx equals x sine x minus sine x dx. U equals cos x du equals minus sine x dx. So this one is x sine x minus or plus cosine x plus c. And that's our solution. Okay. All right. This is something a little bit different. And this one's a definite interval. So we're going to get a numerical answer. 0 to 1 dx over x squared plus 4x plus 5. And so let's see if we can do something with that denominator. Let's say this is x plus 1 and x plus 4, and we have x squared plus 4x. What am I doing? What am I doing? Let's be careful here. I'll choose. This is x squared plus 4x plus x plus 4. So that's opposite of what we've got. That's 5x plus 4. That's not what we want. And x plus 2, let's try x plus 2. X plus 2, that's x squared plus 2x plus 2x plus 4. So this is x plus 2 squared, and to get the 5 we got to add 1, so plus 1. So let's try this. Let's go 0 to 1 dx x plus 2 squared plus 1. Now, that looks like a trig substitution to me, so let's try x plus 2 equals tangent theta dx equals secant squared theta d theta, and we have 0 to 1 secant squared theta d theta, and we have tangent squared theta plus 1. And 1 plus tangent squared theta is equal to secant squared theta, so we have both top and bottom that we eliminate. Oops, boy, I'm getting klutzy here. Secant squared theta, 0 to 1 d theta, and we have theta between A and B, and we got to go back to our original. So we said that x plus 2 on 1, we got 1 plus x plus 2 squared, and theta is arctan of x plus 2. So we have arctan of x plus 2 between 1 and 0, and that means we have arctan of 3 minus arctan of 2. Okay, here we go. X squared e to the x dx And we use integration by parts. So u equals e to the x du equals e to the x dx. V equals, let's try x to the third dv equals 3x squared dx. Let's just give that a try. So we have x cubed e to the x equals u dv, so we got 3x squared e to the x dx. That's what we want. And we have x cubed e to the x dx. Now that's not exactly what we want, because we've gone up in power and we don't want to go up in power. We're going in the wrong direction with this. So what we do is we choose a new variable and see if we can get the same integrand. Remember, I warned against choosing the wrong power in a previous video. So let's see what we got. Let's say that's x squared dv equals 2x dx. And now let's hope we get our integral, our integrand. So we have x squared e to the x equals v du is x squared e to the x dx. That's exactly what we want. Plus, we got 2x e to the x dx. And that's what we want. We want to go down in power. We don't want to go up in power. Oh, my back is getting really bad. So here, rearrange. We got x squared e to the x dx equals x squared e to the x minus 2 x e to the x dx. Here we choose u equals e to the x du equals d e to the x dx. V equals x and dv equals dx. So here we've got x squared e to the x minus, 2. And what we want is we got to do another integration by parts. So we got x e to the x equals e to the x dx plus x e to the x dx. So we have x e to the x dx equals x e to the x minus e to the x dx. So this is x e to the x minus e to the x dx. And now writing this, I'm just going to write it down here. We have x squared e to the x dx equals x squared e to the x minus 2x e to the x plus 2 e to the x dx minus 2x e to the x plus 2 e to the x plus a Oh boy, that's a nasty looking integral sign. I really have a hard time with those darn integral signs. We got x squared e to the x to the third dx. Well, let's choose u equals x to the third, du equals 3x squared dx. And so we have du on 3 equals x squared dx. And now we have e to the u du on 3. And that is 1/3 e to the u plus c, and 1/3 e to the x cubed plus c. And that's a lot more simple than it looked. Initially, it looked like it was going to be a real bear. So we've got x squared e to the x cubed dx, and that's all. Okay, so we got a definite integral. We got 0 to 2 dx on 1 plus e to the x. So why don't we try something here? We have u equals 1 plus e to the x du equals e to the x dx. So dx equals du on e to the x. So e to the x equals u minus 1. So we have take a look at this, 0 to 2 du, and we have e to the u, or we have du over e to the x, and the e to the x is u minus 1. So we got u minus 1 and u. So now let's use a partial fractions. Okay, so we got a u minus 1 plus b u equals 1. Let's try u equals 1, b equals 1, so a equals, I'm sorry, that equals we're going to do a mu minus 1 plus mu equals 1. If we choose u equals 0, we have negative a equals 1, so a equals negative 1. And now we have a broken up integral. We got 0 to 1. We've got du on u minus 1 minus, that's a 2 actually. Let's make that a little nicer looking. 2 and minus 0 to 2 of du over u, and p equals u minus 1 dp equals du. So we have natural log of p minus natural log of u between a and b. So here we have a problem, a definite integral, the arctan of theta d theta is equal to, well, let's not jump ahead so far. That means it's tangent x dx. So we have arctan of x equals theta. That means x equals tangent theta, dx equals secant squared theta, d theta, and we have our little x on 1, x squared plus 1. So now we have 0 to 1. We have theta secant squared theta d theta. We use uv, so u equals theta, v equals tangent theta, dv equals secant squared theta d theta, du equals d theta, and we have theta tangent theta equals theta secant squared theta d theta plus tangent theta d theta. All arranged, we got theta secant squared theta d theta between 0 and 1 equals theta tangent theta, and that's minus sine theta over cosine theta d theta. We got u equals cos theta du equals minus sine theta d theta, and then we have theta tangent theta minus natural log, or plus du on u, and that is theta tangent theta plus natural log of u and theta tangent theta nu equals cosine of theta plus ln of cosine of theta. And now we go back to the original variables. So theta is, tan theta is x. So we have x arctan of x plus the natural log of 1 over the square root of x squared plus 1, all between 1 and 0. So now we have arctan of 1 plus the natural log of, this is 1 plus 1, so 1 over the square root of 2 minus 0, so the first term is 0, and ln 1, which is 0. Ln 1 equals 0. So then what we have here is pi of 4 plus the natural log of 1 on the square root of 2. And that's our answer. 0, 1, arctan of x dx. And that does it. Yep. Oh, but the only problem here is this. No, we've got u. We've got du. So that is a plus sign. Okay. We're all right. We are all right. We could say that ln of 1 on square root of 2 is ln 1 minus ln square root of 2, and then we can have pi 4 plus minus 1/2 ln 2, and that would be another representation of the same thing. Okay, so we got the right answer now. And we're going to call it quits.